Hi, welcome to our last example for section 3.5, transformations of exponential functions. This one is titled circuit analysis. So in a particular circuit, the current I in amps after t seconds can be found using this formula. Okay, so a pretty complicated formula, and basically we plug in the time for t, that little t up here, and we get to calculate the current. It says graph this function using graphing technology. So we'll use Desmos. What is the appropriate domain for the function modeling the circuit? Okay, so let's go ahead and pull up a graph for this. So we have y equals 0.9 times, make sure you're really using these brackets well, minus 10 to the exponent. You may need to put a bracket up here for your exponent. I know in Desmos you don't need it, but it's 0.044 t, and we'll have to use x. Okay, so we'll just close up those brackets. Whoops. There we go. Okay. All right, so there's our graph. Just double check it, make sure everything is written okay. All right, so it says, what is the appropriate domain for this function? Well, I'm just going to zoom out a bit. Kind of cool looking. Looks like every value of x is used. Okay, I know it's really steep on that left side, and then it looks like it gets really flat. Okay, so it looks like it kind of flattens out, you can see. All right, so let's go ahead and we'll just draw the graph real quickly first. We can do a better job than that. Let's redo that. Okay, there's our current in amps. And then here's our time, which is in seconds. And it looks like it's going through 0, 0. So it is. I'm going to zoom out a bit more. So if you look at this equation and you say, what is I of 0? Well, you're going to be putting 0 in for t. So that means my whole exponent is 0, which means this is just 1. And then 1 minus 1, well, that all becomes 0. And then 0.9 times that, well, everything becomes 0. So it is going through the origin. So it's just hard to see maybe where the horizontal asymptote is, and it looks like it's at 1 from the graph. So we're going to mark off 1 here, and we'll draw the curve going up. And then there it is following the HA. Okay, I always label the equation for that HA. Okay, so what is the domain? Well, it's just x is an element of R. Oh, it says what is the appropriate domain? Okay, I'm sorry. So appropriate domain, well, we're using this equation. We probably want time to be greater than 0. So let's erase this, pretend that never happened. Okay, so for part A, we're going to say the domain. We just want positive time. So t is an element of R. T can be greater than or equal to 0. Okay, it makes sense that the situation only accounts for positive time. So part B, what is the current in the circuit after 2 and 5 seconds? Well, we just want to find I of 2. So I of 2, we're going to have 0.9 times 1 minus 10 to the negative 0.044 times 2. That's equal to 0.9 times 1 minus 10 to the negative 0.088. So let's go ahead. We'll get Desmos to calculate that for us. I want to see if it can do this here. No, it doesn't know how to calculate that. Okay. All right. So we'll just plug it in. 0.9 times 1 minus 10, 10 to the exponent, negative 0.088. So that's about 0.165, we'll say amps. Okay. And then at 5 seconds, so it's probably going to be getting closer to the horizontal asymptote, closer to 1. So 0.9, 1 minus 10 to the negative 0.044 times 5. I'm not going to bother calculating that. I'm just going to plug it all right in. So 0.044 times 5. There we go. So it looks like it's 0.357. So it's kind of slowly increasing. It's probably going to take a long time to get close to 1. Like you can see, like if I plot the point on here, it's not till it's like 100 seconds that it's close to 1 amp. Describe what is happening to the current over the chosen domain. The current, we could say the current begins from 0 amps and then slowly approaches 1 amps. Just to go back to the graph, what's kind of nice is it doesn't take too long to get close to 1, but then it kind of seems like it flattens out, which probably could be good for a circuit to slowly reach its way and approach 1, and then it barely changes over time. It barely increases. So, okay, so what is, yeah, I guess that's it actually for this video and this example. I'll be posting these on Teams, and we'll go ahead and fill those out. So, hope you guys found this video helpful, and I'll see you guys in the next lesson.